Hey guys, and welcome back to another video on the channel. In today's video, we're going to be learning how to graph a parabola. So a parabola is pretty much a polynomial or any function that has an x squared in it, where the x squared is the highest term. So what I mean by this is if you have y equals x cubed plus x squared, this would not be a parabola, this would be a cubic, because the highest term is the x cubed term. So we're only talking about functions where the x squared term is the highest order. You might see it as the highest degree. So this polynomial here would have a degree of 3 because the highest order is x cubed. But if we have y equals x squared, this would have a degree of 2. So that's some other terminology for it. Now, let's take a look at what this actually looks like. So all we're going to do is plot an xy Cartesian plane. So x and y. My x is my independent variable and my y is my dependent variable. So this is positive x, this can be negative x, and this is negative y. Okay, so imagine this is just some number line where this is like x is 1 and this is y equals 1. Okay, so that would be the point 1, 1. Right, so if we had, let's say, just the most basic parabola, y equals x squared. How can we graph this? Well, to start off with, it's a function. So a function basically means you input a number and you get a number out. So we input our independent variable into our x and we should get out a y. So think of it as you're going along here and you're getting corresponding heights. So let's go to x is equal to 1. How can we find that? Well, we can find what the y is. Well, actually we should start at x is equal to 0. So x is equal to 0. Substitute that into here. So wherever the x is, you replace with a 0. So y equals 0 all squared. 0 squared is just 0. So our height is here. So the point is 0, 0 here. What about when x is equal to 1? So when x is equal to 1, substitute that into our function here. So replace the x with the 1. 1 squared is 1. So that height is going to be here at 1. So we start to get something like this. Now, what about when x is equal to 2? Well, substitute that into there. 2 squared, and that should give you 4. So all of a sudden, we're starting to get a shape like this. So 4, and it keeps getting higher and higher. So x equals 2, and if you had x is equal to 3, it would give you a height of 3 squared, which is 9. So it'd be all the way up here. So if you did this with every number, you would get a shape like this. Now, what happens if you go the other way? So let's just double check that as well. So we'll keep this information here, but we'll just move it to the side. So what about x is equal to negative 1? Well, every negative term is going to be positive because it's being inputted into a squared. So you'll have y is equal to negative 1 all squared. Negative 1 all squared is just negative 1 times negative 1. So that's just 1. So it's going to be this height here. And you'll see a symmetric pattern. So when x is equal to negative 2, substitute that into there, that's just going to be 4. So you get the same thing here. So you get the exact same shape. When x is equal to 1 and when x is equal to negative 1, the y will be equal to 1. And we can see that right here geometrically. So this is when y is equal to 1. The solutions will be x is equal to 1 and x is equal to negative 1. And hopefully you can see that geometrically. So when graphing one of these, all you need to do is pretty much work out a couple of values for it. So the way I would do it is pretty much just draw a table of values. So I would start from just so I go x and I go y, and I would write my function above it, y equals x squared. Okay. Then all I would do is start from not a huge negative, well, not a very large negative number. So I'd go only to negative 3, and then go negative 2, negative 1, 0, 1, 2, 3. So I have this number and this number the same, just different signs. So this is negative and this is positive. So we already worked out what those are. That's 9, that's 4, that's 1, that's 0, that's 1, that's 4, and that's 9. So this here is a collection of points. So this stuff here articulates our drawing here, because all we're doing is matching points. So if we just had this here, all we need is a Cartesian plane. So 1, 2, 3, 1, -1, -2, and -3. So we're looking for the point -3, 9. So that's going to be up here. So -3, 9. That is my first coordinate there. Okay. -2, 4. That's going to be about here. So -2, 4. And I'm going to move that out the way. And you'll see why in a sec, because I'm going to connect them. So, and this final point here will be 1, -1, 1. And same here, and you'll see this very symmetrical pattern when you connect the points. And all you got to do is draw the lines together. And that's a good enough drawing of it. Now mind you, it's a bit more curved than that. It's more like our drawing up here. Okay? But all you need to do would be to match the points. So this would be -1, 1. This would be 0, 0. This would be 1, 1. This would be 2, 4. And this would be 3, 9. And this is our function y equals x squared. Okay? So that's the most basic function. What if there's like other translations to it? So we can move our function left and right, up and down, and we change its curvature. So let's see what happens if we had y equals 2x squared. So all we're going to do is we're going to have our table of values for our normal function here. But we're also going to have a table of values for our new function. So this was our old one. So we'll go from -3, -2, -1, 0, 1, 2, 3. And that goes, and we know what these coordinates are. Just filling in the table. This is 9, 4, 1, 0, 1, 2, 3. So we know what that function looks like. Okay. Now let's draw another table for this guy here. So still have our independent variables. So our independent variables, so our x values are going to remain the same because they don't depend on anything. The only thing that depends on is the y, because y is equal to x squared. Okay, so we need to know what x is in order to determine our y. So x will go from -3 all the way to +3. 2 and 3. And this is y. So all we got to do is substitute the x values into our function here. So x is equal to -3. Well, substituting that in, we're going to have 2 times by -3 all squared. We know that's going to be 9 times by 2. So that's going to be 18. So 18 is there. And what about when x is equal to -2? Well, we're going to have y is equal to 2 times -2 all squared. We know this bit here is going to be 4 times by 2 is 8. And you'll start to notice a pattern here. This will be 2, this will be 0, this will be 2, this will be 8, and this will be 18. What is the difference between these y coordinates and these y coordinates? They're doubled. 9 times 2, 4 times 2, and then 1 times 2. So I'm only going to draw it for these ones because these coordinates are the same. So this here has changed our y coordinates by a factor of 2. So our curve is going to look something like this. So this is our original curve here. Oh, that's terrible drawing. So this is like y equals x squared. Our new curve is going to look like this. It's going to be more inward because this coordinate here is 1, 1. But this coordinate here is 1, 2. So every single y value has been multiplied by 2. And this goes everywhere geometrically. So hopefully you can see that. So if we have y equals ax squared, a compresses, I'm just gonna go, let's what's a better term for it? Dilates, that's it. A dilates the function. Now we need to be particular with it. Dilates the function towards or away from the y-axis. Now why did I say towards and away? Well, we know it goes towards if a is 2. So if a is a bigger number than 1, it's going to go towards the y-axis. So what I mean by towards is pretty much the bigger you make this number, the more closer it's going to look like this. Now, if a is smaller, so let's go say a is a half. Whoops. All the y values are going to be half as small. So for example, you take this table, and instead of times by 2, you times it by a half. And that would give you, what, a half of 9? So 9 over 2, so 4.9. So you'll have a function. So if you had the function, this one here, and you graphed it, you would have this guy here. It'd be more flatter. So if a is bigger than 1 and goes towards the y-axis, if a is less than 1, it goes away from y-axis. Does that make sense? Hopefully that makes sense. Yeah. So this is part 1 on my graphing for parabolas. So if you want to continue understanding how to graph parabolas, click on the next video.